Suppose that you want to model the height of a rider on a Ferris wheel as a function of time. The amplitude of the function you use as a model should be equal to which of the following: the area of the Ferris wheel, the circumference of the Ferris wheel, the diameter of the Ferris wheel, the radius of the Ferris wheel. Okay, so here's a Ferris wheel. Use your imagination. Alright, so here is my Ferris wheel. Okay, so I'm going to use this and I want to model the height of a rider that rides on this. Okay, so here's what I'm going to do just to make things more obvious. I think I'll draw a couple of lines. This is about to be a giant fat line, isn't it? Okay, let me class up the joint. Okay, here are some guidelines to help you follow what's happening. Alright, here's a guideline, and here's a guideline. Let's see, let me switch to yellow, because these are all just guidelines. Oh, fail. Okay, so I've got these three guidelines. Okay, so a rider, of course, will first get on at the very bottom. You know, there's always some kind of platform that you get on, that you walk up some stairs. All right, and you board the Ferris wheel here at the bottom. Okay, so I'm going to go ahead and throw a y-axis on here. Okay, so boom. All right, say because I can see that my low is here and my high is here, then that puts the midline right here in the middle. So that should be my x-axis, right? Actually, no, because let me change that. I want to model the height of the height of the rider over time. So the height means like the height above the ground. So really, the x-axis should be down here at the very bottom. Okay, like this. Is that still yellow? Goodness. Can I change it? It didn't change. Boo. Okay. All right, so here's the ground. So when I first get on, I'm actually going to board the Ferris wheel right here at the lowest point. My butt is not sitting on the ground. I've walked up a small platform to get on this thing. So that's why my first dot is a little bit up. Okay, it's not on the x-axis. It's a little bit up because of the platform that I climbed. Anyway, as the Ferris wheel begins, I'm going to immediately start rising. Okay, let's say it's spinning this way. So I'm going to start going up. All right, and eventually I'm going to get to this spot right here. So now the x-axis is time. So time has gone by, and eventually I get to this spot right here. Okay, now some more time goes by, and I continue to go around my Ferris wheel. Eventually I'm going to get to this spot right here, the highest. So ultimately I'm going to arrive at the highest point. But then after that I begin to fall. Okay, as I continue to turn, I'm going down now. So I'm starting to fall. And eventually I'm going to get to this spot right here, okay, which is right here in the middle. Okay, you can see it. It's matching right the wheel. I'm right at the middle. And then if I kept going, more time goes by, and eventually I get back to the height I was at the beginning, the height of the platform. So more time goes by, and eventually I end up right here. So it makes this function like this, okay, which looks like a cosine function. Okay, it would be a great cosine function. So now they're asking about the amplitude. Okay, so look at this graph that we just drew. What part of this graph is the amplitude? Well, the amplitude is this part of the graph right here. Okay, the amplitude is how high I go above the midline, or how far I go below the midline. Okay, either one of these is the amplitude. Okay, so this is the amplitude right here. So if I look over at my Ferris wheel, is this amplitude, is that the diameter of the Ferris wheel? No, it's just this part of the Ferris wheel. Alright, it's from the middle to the top, which makes sense because amplitude is from the midline to the top, for example. Alright, so that is the radius of the wheel, not the diameter or the circumference or the area. That is the radius that we just described. So the answer should be this guy.